So welcome everyone to our B-Sides session today. Our session is about AWS and Splunk environments, what we can do, what we could do, what we might want to do. Now, there's two of us doing this session. There's myself, Aleem Cummins. So I'm a community enablement warrior. People might know me for several years gone by. I'm a member of Splunk Trust, as you can tell from the Fez. I've also founded the Splunk User Group London back in 2013 and founded the Splunk Study Group in 2021. More about that later. So I'm joined today by my esteemed colleague, Suman. Suman, introduce yourself, sir.
Yes, I'm Suman Gajavelly, CTO and co-founder of Bits.io. We are Splunk Partner of the Year 2020. I also run Fort Worth User Group. I've been Splunking since 2013. It's my passion to provide solutions using Splunk.
And for everybody, myself and Suman have done a number of things together, including Splunk Study Group, and we've done some sessions. We've got some sessions coming up on Kubernetes in I think April and May as well. So we're very, very busy doing lots of community things. And Suman didn't mention actually, but he does do a huge amount of pro bono work, as do I. So well done for that, Suman. Yeah, so we have a bit of a mixture here of some slides and then hands-on demonstration. Some things lend themselves to each, so we're just sort of splitting it like that. Now we have a Slack channel, and that then flips into the Splunk user group Slack channel. We also have a GitHub repository as well. So all of the scripts that we will be referring to today are available for download, as is the PowerPoint presentation. We'll be putting other materials, so keep an eye on the GitHub repository. That will be changing, and just absolutely keep an eye on that. Now, what we want to cover today is AWS in terms of signing up, what we need to think about in terms of security, instances we can run, how do we access those instances, and then we'll have a look at Splunk. How do we go about deploying it? How might we grow it? Where does Study Club fit in? How can you use what we're doing to help to teach, to help to enable other people, user groups, more small sessions as well. And then we're going to have a look at how do you keep the lights on, because it's very important what we do is sustainable. So we'll be having a look at some of the DNS pitfalls we might have with AWS, and specifically on the free tier of AWS. And we'll have a look at what we've been doing around that. And also then how we can, Splunk, what it is we're doing, and then also Lambda functions. So ultimately, what we'd like to do is the Splunk instances we create, we don't want them running all the time, because if we do, it's going to cost money. So we want to be able to stop and start our Splunk instances to a schedule, on request, and maybe other ways in the future. So the beauty of having Suman here is that he's been doing professional services for so many years and has a huge team. He absolutely knows the stuff inside out, upside down. So we'll make sure that what we have is based on not alone best practice, but reality on the ground. Yeah, so Suman, looking forward to you popping in for all sorts of correction.
Sure, I'm excited, Aleem, working with you on this.
So let's sign up to AWS. So this one we'll just do on the computer because it takes maybe 10 minutes in the real world. We haven't got that. So just pop to that URL, and it doesn't take too long to sign up. It's going to ask you for a few details as you would. It's also going to ask you for a credit card. Hopefully people who use this will have one or access to one, but that's a requirement of AWS. And then it's going to just validate who you are, send you a code, that kind of thing. Nothing much there. Now, in terms of what I've done, I've just gone for the free one. I don't see any reason I'd want to go any higher than that. Would that make sense to you, Suman? Just
free I think so.
Yeah, perfectly fine. So once you've signed up, this is the email to wait for. I think you get 3 emails. This one is the last one. So when you get this email, it means that your account is properly working and you can log in and use it. So we can log in, and when you log in, you got to go through a little bit of CAPTCHA, and it wants to make absolutely sure that it's you, and then you can log in and off you go. So what we'll do is I just want to talk next about security groups. If that was a little bit fast, I apologize. We have a fair bit of content to get through today. So in terms of security groups, within Splunk, we know that Splunk is using network ports and it does connectivity. So this is a chart here from Splunk Docs, and it's kind of outlining the kind of ports that you need to have open when you're using Splunk. And again, it's in a bit of a different tabular format here, but that's kind of a list of the ports you're going to use in terms of the enterprise components that you're going to have in play. Now, on AWS, if you were to use the Splunk AMI that's already available, there is a ready-made AWS security group for Splunk. And on that one, these are the ports that they're having open coming inbound and going outbound. So I think what we'll do for Study Club in this session, we'll just go with that. I mean, the only thing I'd probably call out maybe, Suman, is we wouldn't typically use port 443 because on Linux, if it's less than port 1000, you need like root access. So we're not looking maybe to do that. But do those ports seem okay to you, Suman?
Yeah. So another thing I would like to mention, like the 9997, sometimes we open up for the secure link SSL and all that. I think the port can be 9998 in that case. So as you progress and do advanced Splunking, I think you will be able to use more ports and open up those ports accordingly. But for this exercise, I think these are good ones.
Yeah, that's absolutely fine. That's super. So, I mean, just in terms of, the AWS security group, where does it apply? So just to be very clear, it applies to the instances that you create. So you may have instances of forwarders running in a different domain completely on your local laptops, whatever. That doesn't fall under, they don't apply to the AWS security group. So it's essentially that all of our instances that we create will adhere to that security group. So internally, they can all talk to each other, and then they share the common rules to go out to the public internet and back in again. So just to be clear on that one. So one thing that we'll see, I think, a few times today is the need for keys. So AWS does use keys and insists on keys for connectivity to the AWS instances. Relatively simple to set up. You just create a key pair. It's not a problem. The only thing to bear in mind, of course, is that you can only download the key pair when you create it. Yeah, so just watch out for the pop-up screen there to download and save that file. Because if you don't do that, it's one time only. You're going to have to recreate the instance and do it again. So just watch out for that. Well, that gotcha. So create an instance. And now that we've kind of, we've signed up to AWS, we've had a little bit of a chat about security and keys and that kind of thing. Now what we can actually do is pop in to AWS and have a look. So let's just have a look there now. There you go. There's AWS. Been here before, already spun up a couple of instances. So the kind of things that you'll see here on the screen is that, look, for each of these instances, AWS has got a unique ID. You can see the status. You can see its public address, its private address, the security group that it is adhering to, and the key name that's being used. Yeah, so that's pretty much the standard we're going to be using here. You can see that one of the instances is not actually running. So that means that there is no public IP address. It still is maintaining a static private IP address. But the thing to bear in mind, and the kind of gotcha that you'll get on the free tier, is that every time that you start up your Splunk instance, it's going to have a new IP address, at least a new public IP address. And that's a bit problematic if we wanted to set up an environment and get together as a club and kind of work some things together, help each other to learn. So what we're doing there is we're going to do some tricks around DNS to get around that. And you're going to like that. In fact, at the end of this, there's even a form where you can actually, we can set some of this up for you and you can start to play straight away. So what we can do is we're going to create a new AWS instance. Now, thinking ahead, we want this one to be a standalone, all-encompassing Splunk server. So we want it to be a search head, deployment server, indexer. So today, we're primarily focusing on two instances, one enterprise server, one universal forwarder. I already have the forwarder running in the background because of the time. So let's now go and create our all-in-one standalone Splunk server. So let's launch an instance. So when we do that, we can launch many different instances. We can have a Windows one, we can have a Linux one. I'm going to focus here actually on the free tier ones. Now, Suman, you might have your favorites here. I think I've kind of typically gone for Ubuntu, not for any particularly great reasons, except that I've seen Splunk Education use it. I think they use CentOS. But what do you typically use?
So, since I started 2013, I've seen many customers use Red Hat, and then, CentOS is the free version of the Red Hat. So that's why I usually go after CentOS, but yeah, there is nothing against Ubuntu.
Yeah, I think you mentioned as well before that the ulimit setting might be a little bit different as well.
Yeah, I think it's probably THP, I would think that is different on Ubuntu. But yeah, on the OS level, the memory pages, I think size of the memory pages, I think.
So for now, we'll go with Ubuntu Server version 20. Mm-hmm. And what we're going to do is we're going to pick the T2 micro instance, because that's the free one. And let's have a look at what we need to do. There's nothing to be changed here. Let's look at the next screen. And this is all fine, not changing any of that. And then the next one is add storage. Now you'll notice here that the default size of your instance is 8 gigabytes. Now, the default size is on a Splunk index. When you just install Splunk, I believe there's 9 indexes, Suman. And I believe that the default size is something like 500 gigabytes per index.
Yeah.
So you're looking there at 450 gigabytes. Now that's not going to fit into 8 gigabytes. So one of the tricks that we do in our deployment script is we shrink down our Splunk indexes from half a terabyte to just 500 megabytes. Because for the sort of objectives we're having here in terms of learning, the size doesn't make any difference. We just wanted to run. If we didn't shrink it down, Splunk wouldn't actually work out of the box on 8 gigabytes because it would fall below the threshold by which it would do indexing. So we have to shrink it down, but we'll look at that a little bit later. We're not looking to add any tags for this one. Now, security groups, we talked about this, so let's use the existing one. So there's the Splunk Study Club security group that we previously referred to, and here are the rules for it in terms of the various ports we want to open. So we can just review and launch that. Everything's absolutely fine. A little bit of a summary, and we'll just launch it. Yes, of course, we have to use a key. So we have previously created a Splunk Study Club key. We want to use that. Okay, so we're just going to do that. So that's pretty much it. Let's go back to view our instances. It might take, I don't know, a minute for the instance to spin up. But what I typically do actually here is I might, because I'm planning ahead, I know I want to call this server maybe SH100. So what you can do here, you can have a little label. So I could say SH100. It's not used anywhere, but it's just used when we're in this console to give us an indication as to what the server might be, because there could be a lot of servers over time, because there's no limit as to how many servers we could put up there. So we can see now that it's running. And now that it's running, we can see it's got an IP address publicly, an IP address privately. It's using the Splunk security group name that the security group that we previously created. We're using the right key file as well. So everything is A-OK. Now, with that said, I just want to pop back into the slides because we've done our instance. We're going to have a little look at access next. So the instance is done. Everybody's happy. No problems whatsoever. In terms of Windows, the SSH clients that stand out, we have PuTTY. I'm actually using MobaX Turn today. It's I find that one quite good.
Yeah, I like that too.
Yeah, it allows us to create lots of profiles, things like that. On a Mac, it's built in. You can just use terminal. There's iTerm too as well. People might have their favorites. If so, please put it in the chat as well. But I'm going to go with just MobaX Term today. I'm actually running on Windows 10. Now, there's a little gotcha here as well, because if you went straight away to SSH into your instance and you provided the key, you think everything is good, but it will actually fail. So what we need to do, whether you're on a Mac, a Linux, or Windows, we need to be sure that that PEM file has very restricted permissions. Yeah. So what I've done is on the GitHub repository, I've put in a little script in there for Windows that will take your PEM file and only allow permissions to the user. So let's just say in this instance, the user on your machine was called Aleem, which is me. I run that little script and it will take the permissions you can see on the left, that is pretty much everybody, and strip it down to the right. It's much, much easier on a Mac. I mean, do you typically use a Mac, Suman, or you Windows? Or
Yeah, I use the Mac, actually.
A lot of people do. I mean, it's absolutely fantastic. On the Mac, it's dead easy. You just run one command and job done. I wish we had that in Windows.
It's almost like the Linux operating system underneath. So
yeah,
it makes it easier.
It does. But it took a little bit of research to figure out how to change the permissions, because you can do it graphically or you can just run script, you know. So we mentioned that, you know, in terms of the DNS, that it's all kind of dynamic with the free tier of AWS. If you want to reserve static IPs, you can do, but you'll pay for that. So I think the outcome that we'd like to have here is that, look, we have a domain, let's say, you know, splunkstudy.club, but what we'd like to do is have some subdomains hanging off that, yeah? And every time we want to create maybe a new host, we have a new DNS entry. So rather than depending in our Splunk configuration files for, you know, private or public IP addresses that are going to change, we can use DNS entries, yeah? But it's important that those DNS entries are updated all the time, especially if it's like a throwaway environment. So part of what we do when we have some scripts running, we actually run cron jobs. So every 5 minutes, we make sure that the update scripts are working. Because if you spin up an instance, you know, you wouldn't want to be sitting there for quite some time to figure out, I wonder, is it working? So it's handy that we know a sort of a fully qualified domain name, if you will. We don't need to rely on the IP addresses. Yeah.
So I'd like to mention something. You know, the beauty about this session is you're not only learning Splunk here, but, you know, the AWS, setting up an instance and all that, and then security you're learning, also the DNS and some, at the very end, I think we have the Lambda function introduction. So I think there's a lot to learn here.
Yeah, I think you're right, Suman. And one of the things as well is that we're talking about, you know, AWS, but the logic equally applies to maybe Docker or Azure. So we might find in the future we'll do a version of this that is an Azure one or a Docker one. But the principles are good, you know. So what I have done for the domain splunkstudy.club, I got that on GoDaddy. So on GoDaddy, I've delegated a subdomain, which is, you know, dns.splunkstudy.club, and I've sent that over to dynv6.com. And just a little shout out actually for XPac, my Splunk Trust colleague. He was the one who gave me the insight on dynv6.com, because it's a pretty good site that allows us to do all sorts of clever stuff in terms of dynamic DNS, and it's free as well. So far, so good. So when you go to dynv6, their website, you can actually then, because it's free to join, you can add in that delegated subdomain, yeah? And then when you do that, it will validate it, of course. It will check the DNS entries to make sure that, you know, it's properly pointing to them. But the trick here is we want to make sure we're creating this domain with the multiple zones, yeah? Because what we want to do is have, you know, SH1. If Pune want one of these, they can have one. If Maharashtra want one, if Fort Worth want one, we need to be able to dynamically create these subdomains at will, and we can do that using dynv6. So we couldn't really use this with GoDaddy. So having the ability to delegate some of it away to dynv6.com is quite interesting. So once we have delegated our domain name across here, it appears in the drop-down list, and then we can start to create sub-domains as well. So for this talk, let's create one called B-Sides. And then we go back to keys again. So we saw this with the AWS Access. It's the same here as well. If you want to start updating DNS entries, we want to make sure that you're a properly validated and authorized person. So we can generate keys in various algorithms against the sort of subdomain that we've now created. And this is what that kind of key looks like. It has a name, it's got a hash as well. And when we're doing our updates, we include that hash in the update statement. So it absolutely gets done. So it's reasonably straightforward. I mean, it took a while to get my head around it at first, but once it's in place, it's not a problem. And to be honest, that's part of the reason we're doing the talk today. So myself and Suman go out and do a lot of research and development, and we boil it down into something that hopefully we can all absorb and move on from there. So in terms of the way the DNS is updated, it uses the ns update command. And then this is typically, what gets run. Yeah. So we delete the existing record, and then the A record, that is, and then we add it again. Yeah. And just to point out, if you're ever doing DNS updates, don't use uppercase. Make sure everything is lowercase, because you'll run into problems. I think you might find that a script might allow you to use uppercase, but it's going to cause you problems further down the chain. So that's what the command looks like. And you can see there the fact that we're passing that hashtag as well. So then when you have your script in place, which we'll come on to in a bit, we can then start to see, oh, this is good. I can see that I have instances calling back, and now I can start to do a little bit of tracing. So I can see here, looks like I've got a Splunk server SH01. So what I do is I take the host name, and we create a subdomain for the external IP address, one for the internal IP address as well. So we can quickly discern between which one is the public one and which one is the private one. So we're starting to have a bit of a normalcy around how we, or a convention, if you will, on how we address our server names. Yeah. So we have a little bit of discipline behind that. We think ahead what our naming conventions might be. I guess you probably do this as a matter of course, Suman, in terms of naming conventions.
Yeah, right. Yeah, it's the search head, and in the real time there are indexers. So sometimes we use IDX as the indexer, and the forwarders UF, or sometimes we use heavy forwarders, which are HF. So.
Yeah, so I think, it's fair to say, Suman, that what we're trying to do, we're kind of like, for this talk, you don't necessarily need sort of Splunk experience, but we're trying to find the balance between implementing best practice, but getting started. So if we're trying to learn, if you can learn with best practice, it's all the better. So in terms of our GitHub repository that we've done, myself and Suman have put these scripts up there. So we've got a number of scripts there that you can now go and download and play with and use, et cetera, straight away. They're fully free for everybody to use. We have one here that will actually update the DNS, and I'll show you that in a bit as well. But just a couple of little pointers, and Suman mentioned it was interesting to get little tidbits from different places in terms of the talk. What we're looking to do here is, once we have deployed Splunk, we know where the host name, which Splunk calls the server name, we know which file it's stored in. Can you see there? It's in ops Splunk, etc., local server.conf. So what we can actually do in a script, we can use the grep command, and we can go into that file, take away extraneous spaces, take away server name, and we can then convert that to lowercase. So then we have a proper little DNS tag host that we can then create a subdomain for, and it's nice and clean. And the other thing is, and I only saw this actually in the research and development for the talk, is that how do you know what your public and private IP address is when you're within a Splunk instance? Like, how do you have access to the metadata? So what AWS have done is they've kind of created this server, if you will, that allows us to send requests to it, and it returns back values. So if I ran the one you saw on the screen, it would fire back at me my private IP address, and that's kind of useful. I didn't really know that existed until I mean, that's the beauty of doing talks like these. The R&D kind of kicks in. But so we want to get some settings that we can use to update our DNS scripts, but then we want to apply those. So you can see here we have a forwarder, and it's a deployment client. So here, rather than put in, you know, a private IP address, we're putting now in the fully qualified domain name. And if we have a different box, it will maintain that domain name. If we restart the instance, it will maintain that domain name. So we now have some stability in terms of our forwarders checking in. So that's not a bad thing. So again, we mentioned, you know, definitely plan ahead in terms of your naming conventions, so that when you're doing your configuration, it's relatively simple to know what your convention is and just follow that through. And as you'd expect, if we're running some scripts to do some updating, we're also generating some log files. So in a few minutes in the talk, we'll onboard this log file data into Splunk, and then we'll start to play with that. We'll start to get some intelligence around that. It becomes more and more important, actually, when maybe you're having 5, 6, 7 instances, and you know the amount of you want to know what's going on, especially if there's a number of people in your club sort of collaborating on this. So we can now deploy Splunk. So let's get hands-on, actually. So what we have is we have our Splunk instance, yep, and we can see here that it's got an IP address. So let me connect to that. So I will bring up my SSH client. There we go. Apologize, I have a number of screens. I have to be sort of swapping windows in and out. So what we can do is, I know ahead of time that I'm going to call this server SH100. So I can actually, in terms of my profile for this connection, I can just call it that. But let me go in here and edit the session, right? Now you can see here I've got my sort of fully qualified domain name. Now that's not going to work right now because nothing is sending up any DNS entries for that. So what I have to do the first time around is just use the IP address that has been given to me by AWS for that instance. And in terms of the key, you can see here I've got my private key sitting in that particular folder, and I can give it a bookmark setting if you like, and OK on that. So I can jump straight into my instance. So you can see there it's authenticating that against the key. So rather than install Splunk manually, one of the things that we're going to do here is just run a couple of scripts to do that. So let me just copy across a few scripts. Yeah, we're just pushing up a few scripts to do and these are the scripts that are actually available in our GitHub repository. So let me run that particular script, and bear with me for 1 second. Right, so I'm just picking up the commands. I don't know about you, Suman, but I like to have a list of all the commands I'm going to run. I spent a lot of time in previous jobs running large implementations, so it's very important to know what command you're running, when you're running.
Exactly. I think all the repeatable steps, I keep it handy in a notebook. Yeah.
Yeah, absolutely, absolutely. So we have a script ready to go. So this one is all about deploying Splunk Enterprise. There's a few, you know, arguments we add to it. What's the parent home folder? What's the host name you'd like to use? Do you want to update DNS? And do you want to shrink down your Splunk instance? Now, we mentioned earlier on, it's an 8 gig instance. We absolutely want to shrink it down as well. So we can just run that script. So it goes off using the wget command and downloads the tarball from splunk.com. Now it's expanding out all of the files into the Splunk, the opt Splunk folder. I think it's about 100.
Now, is this running it as a root user or sudo?
So good question. So at the moment we did a sudo there to get it working. So in the first instance, we'll get it working as root, and then we'll change the ownership to, in this instance, the user you're logging on to the SSH session with. Yeah, I think best practice might be maybe create a user, maybe called Splunk. As we already have a user called Ubuntu that I log on to this instance, I'm kind of using that.
So in the field, I definitely would ask people to use create a Splunk ID, and we know what Splunk needs and which files are owned by Splunk and all that, and never ever recommend anybody to run using root.
Yeah, absolutely. So I think that might be a good example of another document we can add to the GitHub repository, just to clarify that. Yeah. So in terms of this script, actually, I could have given it an argument, which was the password I wanted to use, but that's not best practice. So we played with that in the past, and Suman, that's not the way to go. So,
right. Yeah. The clear text we always want to avoid.
Yeah, I mean, just because you can do it doesn't mean you should do it. So the fact we've not done it, Splunk is now asking us the first time around, what administrator username would I like? So let's go for admin. And what password? So I'm going to go for study club. Yeah. Okay. So now that's fine. It's doing its thing. It's installing Splunk. The script does a few more things, like it installs a few of the base apps. So just in case anybody is not familiar with that, assuming I'll just got a couple of commands. You want to sort of mention what the base apps are about?
Yeah. So I think base apps are best practices, and also sets each server its own role. So let's say any Splunk instance, for that matter, has three functions: one search head function, indexing function, and forwarding function, right? But the universal forward, on the other hand, only has the forwarding function. So if for the universal forwarder, we might have some base apps that will have inputs and outputs.conf, for example. Those are the only apps, the conf files needed. But if it's a search head, you only need search head functionality, but you don't need a indexing functionality in real world. And then if it is an indexer, you still need a full Splunk enterprise, but you will turn off the UI in production because you don't want individual indexer to act as search head. So that's because you have multiple clusters in an indexer layer, and you don't want to have any UI available on those. So base apps are basically, it will set the roles of each instance, and also it's easy to go and say, hey, I need to create an index. Okay, I know where to go and create it. So it's kind of it categorizes, compartmentalizes all the things.
Yeah. So what I've done as part of the script here to the install, I've actually created some of those base apps and put them into the relevant folder on this instance, which is a deployment server. Yeah. Mm-hmm. I've actually dynamically written those base files because I've got lots of variables in here. It made sense to do it during the install, but there's nothing wrong with actually having the files and the folders, getting them sorted and just copying across to the relevant folders. But just to make it simple, it's kind of all in the script. Now, So now we have Splunk running. So you can kind of see here as well, one of the things it did at the end of this install, it actually did a DNS update. So it's gone off there, said, look, SH100, this is who I am. So all going well, and let's do a little test. Wouldn't it be nice if we then saw that reflected on here? So let's do a refresh of this page. You can see that it's currently looking at 126. See the 126? If we refresh that, you can now see that it is, what is it now? It is external.
The last third one.
Yeah. So it's got a new IP address. But, if we're using the domain names for our configuration, the fact that it's got a new IP address, it absolutely doesn't matter. So this is kind of handy. So you can see that straight away, the Splunk instance, it ran the scripts, it went off and did its thing. Now, also what we did here, and I want to show you this, as part of the script, we created a cron job. And I just want to show you, the setting for that. So you can see there's the cron job. It's running every 5 minutes. I'm running it with elevated permissions. It's running it in that particular folder. Hey, Suman, I'm sure you're looking at this thinking that's not the place to put scripts. You should put them somewhere else. But just in terms of this example, that's kind of where I put them. Yeah. Maybe I'm purposely making a few mistakes just to let people know that it's not best practice all the time. But definitely do not put your scripts here. I'm also giving it a location to send its log files to, yeah, because further down the road, what I want to do is ingest that log file back into Splunk. But now I can see this is good. I've got a cron job running every 5 minutes. We're always going to be in a good place on every 5 minutes.
Yeah, and I think people will understand that this .sh file needs to have some permissions to be run to execute permissions.
Yeah, yeah, absolutely. And just to mention that the actual base configuration, I've got another script in there that will create those files. Yeah, and it will. But the good thing is actually now that when I'm creating those sort of base files, I can send in as parameters to my script the values that I want to appear in those base configurations. So it's kind of convenient to do this, if you will. Yeah. So you can see, if you're writing scripts, I'd recommend to people try to be as verbose as you can. So the script is giving us a little bit of feedback, so we know, look, I've got some things done. It's copied the files in the right folders. It's good for keeping a track in yourself, but it's also good for education, because we're calling out here, well, these are the folder names that we should use. In fact, if you wanted to have a look at the scripts themselves, I could choose not to copy that. Let me just create the scripts, create the folders for 1 sec, just so we can quickly see them. Take away that copy. So if I refresh this, you'll see there, I've got my Splunk base apps. So in there I have, my deployment client, and in there you'd expect a local folder, and then you've got your various files that you need. So, you can do that manually, or you can do it via script. There's no problem at all with that. Now I have that in play, what I can then do is go on to Splunk and have a look. So I think on my script, I actually have it write out the address I need to go to get to Splunk, which is kind of handy. So let me now bring up a browser and a new window, and I can just type that in. I'll get a warning here because, it's not a signed SSL certificate. Might look to see what we can do about that in the future, but let's go to the advanced and accept the risk and continue. So remember, I think we said admin, and it was study club. Okay. Bingo. So we have a Splunk instance running, and yeah, it's a brand new instance. So we want this is an all-in-one server, so we do want it to be listening to forwarders. So one thing that we want to do is go into settings and have a look at the forwarding and receiving. So some things we're doing. Sorry, Suman.
Yeah. So this is how an instance can become an indexer. So when you don't do this, it just acts as a I would say search head, because it will still index its internal logs, but it won't listen for data from outside sources. So this is the only setting that will make an instance an indexer, which can take data from other sources.
Absolutely, and that's a really good point. And the other point, just to talk about the indexes, we said we shrank them down. Mm-hmm. Let's have a look. So rather than being half a terabyte, they're now 500 megabytes.
Yeah.
So that's all we're going to need. We're not really going to be doing anything heavy here. So that's a little trick. It's in the script. It's on GitHub. Go have a look at what it is. It's not a problem. So what we can now do as well, we can see, I think I already have a forwarder running before, Suman, we set it up in the past. So let's see, can we get this brand new deployment server search head indexer accepting callbacks from those.
So let's look at the search one time and see how many hosts that are sending data. I would expect at this point just one source, which is this one, this instance.
So what we can do is go to index equals internal. So we have. So the reason we have sort of two is that there's a point in time that you install and start Splunk, and then you change its host name. So there's always going to be a little.
It's the same instance, basically.
Yeah. But what you'll find is, because on the forwarder, we use the base apps to tell it to send its internal logs to the Splunk indexer. If we give this about 2 minutes, and I'll come back in 2 minutes, you'll find that the other universal forwarder will be sending back as well. Yeah. It takes a couple of minutes to kick in. But the other thing I wanted to show you as well is if we go to forwarder management, so you can see we have a universal forwarder, UF28 is phoning home, yeah, because we used some base apps before, but I installed the forwarder before I did the search head. But then again, I knew what my naming convention was going to be, which was fine. So in here as well, there's no apps. I think there should have been 2, so maybe I missed a trick there on just putting the apps in the right folders and restarting Splunk. So then we see we have our 2 base apps would have been there. Now, the next thing I wanted to do as well is if I, let me just, what I wanted to do actually was go on the, I know what we need to do. So we have a log file that we had for our DNS updates. So why don't we ingest that log file as a little bit of a test? So we can go to add data. And we're going to monitor a file. Now, the file we're going to monitor is a directory folder. So we want to monitor our log file from the DNS updates. Yeah. So if we go next, it's going to pick it up. I've actually used epoch time for the time here, just to make it easy for Splunk. So that's fine. It recognized that. The logging format I decided to use was key value pairs. I don't know what your sort of preference would be, Suman, in the field.
No, I think that's fine. So just wanted to see, when you gave update time, is it picking up? Splunk is picking it up, or did you give any settings on the left hand side?
No, I just went for epoch time because I knew that was going to be really nice for Splunk.
Okay.
Just on automatic. Kept it sort of simple as I could.
Yeah. So in the real time, I just would like to mention this. Splunk is smart enough to figure out where the timestamp is, and it can pull that out. But in production, though, I would like everybody to go through the advanced settings and just tell Splunk where the timestamp is, and tell Splunk what format it is in. That way, it doesn't have to go through this every, in production, you might have millions of events coming in, and it has to go through an algorithm to figure out the timestamp and then what format it is. It's going to take more time. So in real time, I would recommend that you set the timestamp format and timestamp prefix. It will be 10 times faster easily.
Gotcha. Excellent. Thank you so much for that.
Sure.
So we need to create a new source type because that was a new file that Splunk was, unfamiliar with. So we'll just create a source type in here and then just save that. So we can create a new index if we wanted to, but I have one called main. We'll just pop it in there. So what we can then do is we can submit just to finish that off, and we can start searching straight away. And in fact, what I'll do is I'll just have a slightly cleaner search in there. Yeah. So now you can see in here, Suman, that we have our update time, what DNS server we were using, the instance of AWS, and then these are the external names of our hosts, the internal names of our hosts. So now we're ingesting that file. Now what we can actually do is, just for a second, I'm going to pull in some data from our universal forwarder. So I have one here already. I'm using a fully qualified domain name to get to it. So here I'm in, which is fine. So there's a command I want to run to tell it to monitor the same log file. Yeah. Oh, actually. I need to, that's now not working. So what I need to do is, give me 1 second. So it's not so happy with that DNS name for some reason. So let me quickly pop back into here. And I know that for the folder, Oh, it should be fine. The domain entry is there. In fact, I can check it. 211 while I'm here. So 211. So that is 211. Yeah, so it is there actually. So we have some kind of resolution going on, but not to worry. Just for the moment, let me go back to the fixed IP. And then let me just run into that. So we can run a command here as well to tell the Splunk forward to monitor that very same log file, tell it what the source type is, and tell it what index that we want to send it to. It already knows where to send it because in the base files we specified the outputs.conf. So I need to log in here as well. So admin and
this is the universal forwarder.
Yeah, that's the universal forwarder. So now it's added a monitor for that. So now if I was to go back into Splunk itself, and we did a bit of a refresh on that, we now see we have entries coming in from that folder. Yeah. But if I wanted to go maybe one step better and see, well, when did the IP address change for each of my hosts, as opposed to showing me all of the DNS updates, what we could do here is, there you go. So for this server 100, actually that one hasn't changed. For that to change, what I'd have to do actually is stop the instance and start it again. But that takes 2 minutes, so we're not going to do that. Yeah, but this is just a cleaner way to show you when the IP addresses change. So now we can see, look, we've run a script. We've deployed Splunk. We've done the base apps. We have forwarders calling home, all using DNS, not IP. And we then have the internal log files coming forward from the forwarder. We have the log files for the DNS scripts coming forward from the forwarder. And as we have more and more instances, it gets a little bit easier using Splunk to start to get a handle on how many instances are we running, what's the DNS, and maybe we can improve this to actually show you what ID, what username was used to run the actual script. We've not done that. We could do that as well. So that's just an example there. So that is kind of the hands-on for that particular portion of it. If we pop back into the slides for a second, you can see there, look, we had our log format, and then we did our update. So we've gone through this, so we don't really need to, go through this again, but at least it's on the slides for people to reference and read at their own pace. So there you go. Yeah. So with one we had previously prepared, we took the opportunity to restart that instance, and you can see there in that circle, that's the point at which that IP address did change. Yeah. And if you have a look at the update time, you'll kind of see here that the cron file, the cron schedule is every 5 minutes. So that's why you can see that the updates are running every 5 minutes. If they're not every 5 minutes, it might be because there was a manual update done. Yeah. And then there's the Splunk search that we ran, if anybody wants to play with that. Now, in terms of, and this is a shout out to JCat54 from Splunk Trust. Like, we don't want our Splunk instances to be running 24/7 if we can help it, because we have to pay for that. And I think part of the reason that we're doing this talk is that we're trying to empower people who, we haven't all got unlimited resources. We want to be able to learn Splunk as best we can at the right price. Okay, some people are learning Splunk in their own time, and maybe they don't have access, to the funding that companies may have. So we want to be sure that we're providing solutions that are good for everybody in terms of your learning, but also in terms of your pocket, and make it sustainable. So we're using something called a Lambda function. Now, this is new to me. I didn't know about this only a couple of months ago. So what a Lambda function is, it's something that allows us to control our AWS EC2 instances. Yeah. So what we'd like to do here is very simple. We either want to start up our instances or we want to shut them down. Nothing beyond that for the moment. So if you will, for us to get to that AWS Lambda function, where does it run? I mean, what you wouldn't want to have to do is have a server running all the time to run that function. So what we're able to do is use serverless access to that function. So AWS has an AWS API gateway, and the beauty of that is it can then access your Lambda functions and control the instances you have on EC2. So you don't have to have your own server running to do this. You can take advantage of the API gateway, which is kind of cool. So we pretty much want to stop and start. That's what we want to do. Have you done anything yet with Lambda, Suman? Know of anybody?
Yeah, in AWS heavy customer engagements, they use a lot of Lambda functions to export or import data into Splunk or out of Splunk. I mean, there's a ton of functionality with the Lambda function, what it can do. And I think it is only specific to AWS. It's there is equivalent to Lambda in Azure, but it's called something else, or in GCP as well. But yeah, this is a trademark of AWS.
Yeah, I mean, when I was doing the research on this, it was so exciting. It seemed insulting just to have a Lambda function to switch off and on, But the URL down the bottom of that slide is quite good. That's where I kind of got a lot of the research for this. But you also have to figure out the permissions. We talked about keys earlier on. So here we have to create a policy and a role in order to give that Lambda functions their permissions to execute, So what we need to do in a nutshell is create our policy, create our role, and then we create our functions that will sit under those roles. And then we use our API gateway to execute on those functions. Yeah. So I'll kind of show you how you do this. I'm not going to do this as a hands-on. I'll do it as slides just because of the time it takes. So you want to create your policy. You do that on the AWS console. And you don't need to add any tags. What you need to do for these Lambda functions, apparently, they need to have access to the CloudWatch logs and also EC2. That needs to happen. And then when you want to create your role, now that we have our policy, the role, what's he going to do? So we have a sort of a template one here around EC2 that we just go with. And then we want to give our role a name. So let's just call it Splunk Study Club Instance Control. So then, again, we're not going to do any tags for this. Maybe you could. I don't know any better, to be honest, at this moment in time. So give this role a name. We've done that absolutely fine. So now we have a role. So now we have a policy. We have a role. We now can start to create some Lambda functions on AWS. So when we're creating this, we can give it a name up here. It's hard to see that. I apologize. Let's give it a name like Stop Instance, something like that. And it's going to, the runtime will be Python 3.8 for this. But the existing role is the one that we just created a second ago. So that's where we tie up the Lambda function to the role back to the policy. So once we've done that, we then have, there you go, there's our Lambda function. You do that in a few clicks. And our little bit of code we have in here specifies the instance ID, which we saw in the DNS script, of our AWS instance. Now, at the moment, I'm kind of typing those in. If I spend more time, I'd like to be able to programmatically figure out what they should be and, stop and start whatever instances we require. Right. But this is now not being, when does this start? We have to have some kind of a trigger. Yeah. So what we can have here is a number of triggers, which is really cool. And one of the triggers that stood out to me was the Alexa one. Though mind you, I can't imagine saying Alexa can just spin up my instances on AWS, but apparently you can. So we're just going to go for the API gateway on HTTP. Yeah. So once you do that, literally, if I was to type in that in red, what you see there, that would stop my instances dead. Yeah, that's it. End of story. But there's so much more I'd love to do around this. It's really teasing. So I think, Suman, we'll do a follow-up session possibly in May, June.
I think so.
Because the idea here is that we have a modular approach, yeah? So what could you do once we have, a sort of a baseline of a Splunk instance? Do you want to do something to add some data generation? Do you want to do something to do some regular expressions? Or, there's lots of things we could do. So we're kind of in a modular approach on this. So now, after we've done that, bingo, we now are able to manage our AWS environment. We can keep our costs down to, well, hopefully free, all going well. But then just, we're in the final sort of few slides now. In terms of the licensing, there's a few options here. We have the 50 gig one that anybody can have, there's the URL for that. It's limited to a single instance. Or if you want to, if you're more into it, you might want to go for the developer license. That's a 10 gig one that allows clustering and the full support. And if you have an enterprise license, you can potentially do other things. I don't want to talk too much on the licensing now. I just want to tell people to make sure you're applying the right license and doing the right things. But we'll probably have follow-up sessions on, when we go forward with Splunk Study Club, what licensing works best, Yeah. So just in terms of Splunk Study Club, and I really appreciate your help on this, Suman, as well. What we're trying to achieve here is that, look, let's do some of the blueprints. Yeah. So rather than we have all these user groups and they're all doing their own thing, let's create a way for people to spin up Splunk environments. Let's find a way for people to be able to publicly say what those environments are, because we now have static DNSs, if for want of a better word. So we're trying to create some frameworks and some blueprints for user groups and study clubs to be able to get on and learn Splunk, yeah, rather than get stuck on the nuances of deployment and do I go to Azure, do I go to Docker? So that's kind of where we're coming from. So it's always going to be free for everybody. So we have good people in the background who are going to make this happen. But ultimately, if anybody wants to do what you've seen today, please, by all means, we have a request form on Google. That's the URL. If you go there, you can request a delegated subdomain. I'll create you one. Use the scripts we have on our GitHub repository, and then off you go. We also have, the Slack chat as well, so we can start to talk about this. We can start to maybe do more. It's all about empowering. It's all about learning. It's all about knowledge, and it's all about sharing. So user groups sometimes can be a bigger crowd. Study club, maybe it's a few people around a table. Because essentially, Suman, today's study club, there was a few things I did, but with your vast experience, do you know what? You should do it a different way. Yeah, so this has been a study session, a study club for me, and I'm very grateful for that. So that's kind of where we're going in the bigger picture. So if anybody wants to contribute in terms of time, in terms of resource, please do.
Yeah, I think the next session that you talked about in the beginning, those are going to be very useful as well, because they are going to be focusing on containerization, like Kubernetes and all that. And I think in the future, we might be able to do, I think we might start with AWS or on our local, creating a Docker, but we can always do this in AWS, Azure, or Google Cloud as well. So I think we can have those series of sessions going forward under different technologies.
Absolutely. I think if we can do some of the research and development, it just helps the community. It's all about helping the community. So that's a little look, a big call out as well to Rich, Clara, and Tony for the work they've been doing, putting B-sides together. There's a lot of talks, today, tomorrow, yesterday. Really grateful for the efforts they've put in. It's just incredible. The amount of work people do behind the scenes is incredible. So I hope that the people watching this, whether live or whether after the event, are happy with what they're hearing. But certainly, please go to GitHub repository, go recreate what we've done. If you've got a better idea, please share it with us, and then we'll share it with everybody else. So Suman, I think that's our 60 minutes. Bang on.
Yeah.
So thank you so much for your time.
Thank you as well. It was a pleasure working with you, Aleem, and we'll help the community with this initiative.
We absolutely will. Have a great rest of the B-sides, everybody, and we'll see you at .conf in October.
Thank you, everyone.
Thank you.